So when you're solving exponential equations, guy, that means you have your variable is now as an exponent. Brooke? According to a whiteboard, no, ma'am. Okay. So if I give you an exponential equation, some base raised to the power of x equal to some base raised to the power of y, and the bases are exactly the same. So guys, if the bases are exactly the same, for these two equations to be equal, the x must be exactly the same as the what?
Y.
The y. That means the exponents must be the same. Hi, hon. Where's your cell phone? Okay, go fine. So for any equations, okay, to be equal to one another, in this case, we're just talking about exponential. If the bases are identical, then the exponents must be identical for them to be equal. So Joe, can you help me with number 1?
Isolate the base.
Yep, isolate the base, just like isolate the radical. Can you please, Maddie, I can't talk right now. Help me read number 2.
It's not here.
Oh yeah. Maddie L is not here as well. Okay. Hunter, read number 2, please.
Write each base as the power of the common base.
Perfect. Okay. So each base, make sure you find a common base and write them to make sure they are the same at times. James, can you help read number 3?
Exponents equal to each other.
Only when the bases are written in the same. Lena, just wants you. Good question. Victoria's not here. Oh my. All right, Chance, can you help me read number 4?
Solve as a simple equation.
Perfect. So number 1, example 1, 3 raised to the power of 5x minus 1 equals to 81. As you can see, the bases are already by itself, but the bases are not identical. So what you need to write is make sure the bases are identical. Is it possible? How? We cannot move it like that. Make sure the bases are the same first. So right now, the base, what is the base on the left side? 3. Is it possible to get a base 3 from the right side? Write each base as a power of a common base. So how would I write or rewrite 81? 3 to the 3 to the what is 81? 4th, right? So that's what it means on step 2. So on the left side, we have 3 to the power of 5x minus 1 equals 81. You can rewrite that as a power. That means you have a base of 3, and what is a power? 4. Okay? Now check out the bases. Are the bases identical? That means you can drop the bases because for it to be equal, the exponent on the left, which is 5x minus 1, must be exactly the same as the exponent on the right, which is what? 4. So now your job is to solve for x. Okay. So, Miss Amanda Ross, how do we solve for x from here?
You subtract 1 or add 1 to both sides.
Good. Add 1 to both sides. So now 5x equals 5. That means what do you divide both sides by? 5. So x must come out to be 1. So when x is 1, this will be a true statement. Okay. Number 2. Step number 1 said isolate the base. Right now, what do you need to do is isolate the base on the left side.
Add 7.
That's right. Add 7 to both sides. Oops, 7, not 5. Add 7. So that means you got 4 raised to the power of a plus 3 equals 25 plus 7. Brooke is? 32. Look at the bases. Are they identical? No. Can I make them identical? Yeah? 4. So we have Hannah said 4 times 4 times 4, 32. Is that true? No.
4 times 4 times 4 is 60.
Right.
4 times 3 or 2 to the power.
4 to the third, which is 4 times 4 times 4. That's not 32. Okay.
Power of 5.
Huh?
2 to the power of 5.
Ah, can I break it down to base of 2? That means this base of 4 is raised to a power of what? 2. And then that's 2 squares 4. But then I have original power of a plus 3. Now on the right side, 32 can be broken to the base of 2. Raised to what power? 5. Now, we must do what with this exponent right here on the left side? Multiply, because power to the power, you must multiply. So when I multiply that, what do I get? 2 to the what? 2a plus 6 equals a 2 to the 5th. What do we do now? Drop the bases. You're right. So now the exponents are 2a plus 6 equals to 2. Can you please help me, Carly?
Subtract 6 by both sides.
Good. So now we have 2a equals to negative 4.
Why is it equal?
I meant, where are we at? 5. Thank you. Ooh, good eye. 5. So subtract 6, so that's going to be a negative 1. Thank you so much. Then divide both sides by 2. Then a comes out to be a negative half, and we box that up. So we, at times, these are easy, so that's why it's called easy, because we can rewrite whatever it is in a common base. Okay, I want you to try 3 and 4 out on your own for 2 minutes. Let me make it bigger so you can see the question for those of us who don't have printed notes. So 3 and 4. Try it out, Joe. Once you have an answer for 3 and 4, 4, 3, or 4, then you can talk to each other, compare answers. Hey, compare answers to each other now. Since I you already have the answers boxed out.
Do you get any smile? Okay.
I got 5 and negative 7.
Subtracted. Do that next.
I got 5 and that's negative 5.
Divided by negative 1.
I got 5 and negative 7.
I just made the base 30, so I just put x equals to 2.
If you can do 5, yeah, and 6, that'd be amazing.
And then,
Yeah, you got negative 7, 5, right?
yeah.
All right. 3 is pretty easy, right? The bases are the same, so you can just drop it and then solve for x. So, Hope, what did you come up with for the final answer for 3?
X equals negative 7.
Negative 7, like that?
Yes.
Do you guys agree? Yeah, perfect. Now, 4 requires a bit of work, but not much more. You can't drop the bases right now, but what can you do with the 49? 7 squared. Then you can drop the 7. So, final answer for number 4. What did n come out to be, Daniel? On number 4? Okay, why don't you try, and then, did you try on your notes? So Daniel, what did you, can you go back to example 1 and tell me what we did in example 1? Right. Why did we do that, Daniel?
To simplify and get the same base.
Okay, once the bases are the same, what do we do after?
Take away the base and the threes.
What allows us to drop the bases?
They're the same.
Yeah, so and then what do we do after we drop the bases?
You subtracted the 1. Oh, wait, you added the 1, sorry.
Yeah, so we took the exponents, right? And then we set them equal and then we solve normally.
Yeah.
Now on example 3, what did we do? Are the bases already the same?
Yeah, so just take the bases away.
And then just use the exponents, right?
Okay, and just subtract that.
Now go ahead and try number 4 for me, Daniel.
Just 5.
Just 5. Do you guys agree, Daniel? Good job, Daniel. Now, 5 and 6. Raise your hand if you can or already know how to attack 5. Hannah?
Would you make it 25 to negative 1?
Do you think that's a good idea? Should we make 25 to the negative 1 power?
Yes.
Yeah. Let me remind you guys quickly. Remember when we had x to the negative 1? And I said, oh, okay, how do you make it into positive exponent? We write 1 over x, right? Same thing with numbers. If it's in the denominator, you can move it to the top and use an exponent of a negative. So 5 to the power of x minus 4 equals 25 to the negative 1. Well, are the bases the same?
No.
No.
5 to negative
So rewrite 25 as a what?
5 to negative 2.
5 squared, which is, that's right, it is negative 2, okay, because I'm going to multiply my powers. So we got 5, negative 1 times 2 is a negative 2. Now you can drop what, Daniel?
The bases.
Yes. So now we have exponents of x minus 4 equals negative 2. James, find the answer.
Negative 6.
No. 2.
Wait. What? Yeah, 2.
Add 4 to both sides. So negative 2 plus 4 is 2. Whoa, number 6. This looks scary, isn't it?
I know it is.
What base did you use?
I used the base of 3.
Do you guys agree? Okay. Let's see. 9, I would rewrite that to 3 squares, 9, right, class? The original power is y plus 7. Well, 3 to the what is 243? To the what?
4.
4? Do you guys agree? 3 to the 4th is 243. Well, 3 times 3, that 3 squares is 9.
It's 3 to the 5th. Or 5th.
Okay, 5th, thank you. So 3 to the 5th. Before I can drop the bases, what should we do with the powers on the left? Distribute. So here we go. 3 to the 2y. Remember, this is power to the power we multiply. 3 to the power 2y plus what? 14 equals 3 to the 5th. Now we can drop the bases. So 2y plus 14 equals to 5. Subtract what, Dylan?
Subtract 14.
Perfect. So 2y equals 5 take away 14 is? Negative 9. Divide both sides by 2. Final answer, y is negative 9 all over 2. Box it up, and that concludes our day.